Okay, so today one of the more unusual walkie-talkies for CB2781 is the Harvard WT44, and these came a little. Whoops! Turn the light off, not on. Why is it so dark in here? It's been my eyes. It's supposed to be 4 watts. So I have a circuit diagram here because we bought one new at the time and it was on the back of the instruction book, luckily. This is blown up massively. Output transistor, I think it's another MPSU 3.1 like the Harvard, oh come on, Harrier CBH2, WT2, Alba CBH2, yeah, you know the one I mean, Harvard 410T. So it is the MPSU 3.1 from Motorola, which is very, very expensive. And of course, if you've got a duff aerial, it destroys the output transistor. This has been passed on to me by a viewer who was a customer, a trade customer. The good thing here is that you've got external aerial, external power, external charger, and high-low power actually on the side of the set. But you don't have external mic, so you can't use it kind of in your car, can you? But at least we can do an on-the-air test from here, where I can actually pick this up from the bench, having it plugged into the roof aerial. The other thing we can do is to actually go out and do a field test. But we've got a snag. The snag is the aerial's broken. The top element is totally glued in, and there's a nut there, and the second to the top aerial element pulls out. Now, these are also very similar to the Eurosonic EU40. We've covered this before, the EU40. It's quite clearly out of the same factory. It's probably a very similar board if we bothered to go inside. But there again, we've got a broken aerial, so we can't do anything with that. So, what can I do? I can put that back on the shelf and fetch something else. What we're going to do is we'll borrow the aerial off this WT2, which hopefully is intact. Yes, it is. And we also know, because we've got this intact antenna, how long these are supposed to be. So, whoops, knocking the overhead camera. So we're going to pull up this one as well, because the other way out of this is to stick a piece of welding rod or whatever in the top to an exact length. So if I pull both of these sets down, they're both fully telescoped, and you'll see we're that short on the broken one. But I think this is not something we can sell on because it's got a broken aerial. But we can borrow the aerial from the WT2. Now, we haven't done the WT2, so it would also seem sensible to then return the borrowed aerial to the WT2, do a service on that, and then we can do an on-the-air test with that as well. Now, WT2 is a 2-watt radio, not the best receivers in the world, and all these sets with this case from this manufacturer are best described as fragile. You don't drop them. So I'll put that on one side, because there's no point borrowing the aerial off it yet, because we may never get this to work. So we need a trusty power connector for that, and it is negative inner, not positive inner, negative inner. So isn't that wonderful, folks? Now if I've got some ones intended for Maxcom 7Es. It's only 1 amp wire, but it will be adequate, hopefully. And this is going to be positive inner, so we'll have to connect it the wrong way around. Obviously we could make up a lead for it, couldn't we? So that should be positive, that is positive. Let's put the bleeper on. Yep, that's negative. Yes, so if we wire this the opposite way around, we're okay. These are 12 volts, and I think they are 12 volts. I can look at the instruction book. I've got it on file, and I'll just see what it really is. But first of all, we'll just see if it powers up. I'll just strip some of this insulation off. I'll have a look at this. I'll tell you what we might do. We might borrow one of the connectors we make for the 77805. I'll go and get a page from the instruction book which tells us the specification, and I'll come back with a 77805 lead and just see whether that is a little bit, well, we know we've made them for 3 amps, but if it actually fits, even if it's reverse polarity. So the reality is that I can no longer find the file for any of the Harrier handhelds, which isn't surprising because we seem to have lost 2/3 of the red binders which the handhelds are in over the last 40 years. Luckily we haven't lost the realistic one or the binatone one. So I've looked in the filing cabinet and I've looked in other places. So we're stuck with what we've got on file, which is the circuit diagram only. We're going to guess this is a 12 volt radio, so we're not going to exceed 12.8 volts. It says 12 volts on it, and I doubt it's intended to be operated in a car with the engine running. So we need an adapter, which is a 3.5mm jack plug mono to an SO239. But we haven't got one of those. But in the past I've made up an adapter to a PL259, so we'll put that into a PL258 coupler. But you see, we're going to end up with an adapter tree here, and it's not going to be kind of the real readings because of the attenuation the adapter tree is going to cause. So we'll now plug that into the test set. These are inherently lossy. If it was BNC we'd be okay, but we're not. So we switched on 12.8 volts, maximum I dare go, current limited to 1.2 amps, and we're on channel 20. Can we see the channel 20 in that window? So I'll switch picture in picture on, and let's see what happens when I press transmit. Wow, it works, and it does 2.8 watts. Not sure why I put the circuit on the clipboard when I want There's probably nothing wrong with this other than the Duff aerial. I've serviced one of these last year for a customer, but we've probably got one. We will have got one somewhere, but this one has been passed on, as I said, to me, and we may as well do this and do a field test with it. So at the moment we've got whatever I said. I'm going to now put 3 watts because that's the reality. And if I can get an electron microscope on this channel selector, channel 1, .9 watts, channel 40, .6 watts. Low power. Let's go back to channel 20. Low power. 450 milliwatts. That's illegally high. And transmit current back to full power, 550 milliamps, which is very efficient. Put the deviation. Wallow. So it's 2.7. So we'll take that with a pinch of salt in case the test set is playing up. And frequency, let's go. So the good news is there isn't any corrosion underneath. You need to be taking 4 screws out. 1, 2, 3, 4. And this screw and that screw are held in by nuts and bolts, so they're not to do with the pillars which hold the printed circuit board in. So unlike the horrible little flat speaker you got on the Harvard 410 and the Alba and so on, this doesn't have that. It's got a sensible speaker. Notice it's 16 ohms. So we're connected to there, so I'm hoping we'll put the crocodile clip lead actually on the speaker, and we should only need the positive and not the negative. So connect the aerial back up. At least it's all plastic so it's not going to short out. Need the power back. Hello power, where are you? There. And we need to be able to connect to our test speaker, which I say test speaker, test instrument. Yeah. So you can see what a faff it is. We want channel 20. Okay, let's see what we've got. So for 12 microvolts, 12 dB, sorry, for 12 dB SINAD, it's 1.7 microvolts, which is not good. For 10 dB, it's 1.25. Will it ever do 20? Yeah, it will. It's 4.8. Now some of this will be my adapter tree, won't it? Yes, Mr. Tango, it will. Squelch. Let's turn it to full. It's usually pretty wishy-washy on these sets. I've just knocked the test set off frequency. And I've put it back on. Let's have a look. Full squelch. It's 10 microvolts. May not be able to improve that. And squelch threshold, I need to try and clean both these controls. It's 7 microvolts. I need to be able to improve that, don't I? Right. See whether we can improve that. So, back to the circuit diagram. How's the detector done? It's done there, so T4 is going to be the detector. Double diodes. Without taking the thing apart, that is surely going to be it. It's a very simple receiver. More simple than the Harvard 410. So I'm going to put the oscilloscope on. Just go over to the oscilloscope. 100 microvolts on. Let's see whether we can adjust that. It was already spot on, it didn't need adjusting. So go over to the SINAD meter. There's something on top, isn't there, in the camera's view? Is that any better? No. Right, drop that to, it don't go much lower than 6 or I'm not going to be able to hear it. It doesn't work like a normal set. So we've only got 2 adjustments, 3 adjustments. Start here. Very slight improvement. Very slight improvement. I don't know about that one. That's it. Let's get a new reading. So for 12 dB, believe it or not, we now have 0.85 microvolts, which is where I'd expect it to be. And for 10 dB, 0.7 microvolts. And 20 dB is now 2.3. So hopefully the squelch will work better and we'll be able to adjust it. So for Turn the squelch to full. I haven't got an applicator, so I can't spray the controls yet. Let's squelch at full. Just get it on the threshold and see whether we can adjust that. I'll tell you what, I'll put it to full and see where that brings us. Brings us to 9.5. Wouldn't be any good as a base station, would it? Right. But it's not meant to be. Set the threshold. It's now 2 microvolts. It's pretty lousy. Right, I'll put the set back together. Right, let's see how this WT2 is. Oh, that's a nice battery compartment. High-low power on these is stupidly through the back. Right, let's see whether we can get this. Is there a screw in there? Sometimes there isn't. See, it's a totally different board. Got the MC3357. It's still a pretty simplistic receiver, but on the face of it, it looks better than the WT44. But there's a lot more wiring in this, and you could think it's more costly to produce. So it's the same aerial. What we're going to do is simply borrow it. It's not that screwdriver. There's probably no screwdriver I've got on here. So these are glued in as well. What I'll do is I'll screw that back. So we don't lose it. Probably next week we'll look at this one and then we can test it, because they do perform very differently. Because until I fit this, I can't set the loading coil there. So you don't often see an intact one of these. These don't have any glue in them. There is an EU version of these handhelds. That might be a cheap source of, was it somebody's DNT 4000 or something? Because there's little interest in CPT, that is a possibility of a cheap way of getting an intact aerial. or borrowing it. The star washers between the two. Right, so now we need to pull up the telescopic aerial and making sure it doesn't touch anything, like the next bench. That's fully extended. I am going to have to hold on to that. We need to get a field strength meter. Just see if that will balance it. I'll tell you what, our walkie-talkie will balance that up nicely. So back onto power. Switch it on. And now we're going to be transmitting on that antenna. So I need to get a field strength meter out and we'll take it from there. Right, I've got this Binatone one. These are really nice STPR meters. I can record they go up to 2 meters as well. And this one I paid far too much off eBay for because it had the little aerial with it still. So I'll press transmit. As you can see, we get it where I can see it and where the camera is are two different things. It's going to be a good demonstration, isn't it? See if we can plonk it like that. Yeah, that reads. That's field strength done. Good. It should be cracking out now. We'll be putting 12 volts worth of batteries. I don't know whether we're using rechargeables or whether we're using throwaway batteries, but whatever it is, will be the right number for 12 volts. Where did I put the box for this? Yes, on top of the clipboard. I probably paid a stupid £20 for it, but look, they paid £8 for it, so that was a good profit for them. Well, they deserve it then. Right, I'll carefully put my aerial down. Oh, I need to clean those things, so I'll come back with some cleaner. So on the face of it, these are a sealed type of control, but we can usually get somewhere with them by going through. I'll just turn the power off. I'm actually going through these rivets. The volume control isn't very dodgy, but we'll do that. See whether that's any improvement. Oh, well, it likes it when there's an aerial connected. One on a Roger. Well, we'll do an on-the-air test from this bench on the roof aerial, and then if we can get batteries to work in it, we'll do a field test with it. So thanks for watching one of the more unusual hand portables from 1982, the Harrier WT44, and thanks to the viewer for sending it in.